Hiya. So today we're gonna go back a little, or in this video we're gonna go back a little and talk a little more about conditional probability and tree diagrams. I kind of went over this really quickly in the last two videos, so I really want to put this home as to how this is working because it's, I think, a little bit confusing in the beginning. Uh, and we'll end up with a nice law that kind of breaks things down on how to multiply things. So let's kind of do this is basically like a big review, kind of. So we're going to look at the three bags of chocolate example again. And remember how we had this tree diagram. So basically, if you think about this, how we were talking about the conditional probability with the tree diagram. So let's break it down and let's look at one of these lines. So the line I'm going to look at is, we'll look at this line here. So we'll take this path, and then we'll take, I guess we'll look at dark, right? So dark path. So the question where we were asked in this example is, what's the chance of dark chocolate? So the probability of dark chocolate, right? And so the probability of dark chocolate is actually going to be the sum of three different probabilities. So this is the sum of the probability of dark chocolate. So I'm going to use the symbols that we had from before. So we have W for white, D for dark, and M for milk. So here I'm looking at these ones here to make life easier. And so what I have is I'm trying to figure out the probability. So let's erase this because I'm going to need more room. The probability of dark. Well, so this is just going to be equal to the probability of dark given bag 1, plus the probability of dark given bag 2, plus the probability of dark given bag 3. And this is basically where these lines are coming from, these green lines, right? So the probability from bag 1, there's no dark chocolate, so it's automatically 0. So for our purposes, this is giving us 0. And then these other probabilities, what we have is, that's why we're getting these other two things. Sorry, not given. This should be and. There we go. That we got dark chocolate and is from bag 1, that is, etc. Now, each one of these, we can break down, right? And this is what these lines are coming from, right? So this is equal to the probability of bag 2 times the probability that we have dark given that we had chosen bag 2. So in other words, what this is saying is first choose bag 2 and then choose dark chocolate here. So we have to add the information that we're given bag 2. And so this is how we would write that out. And this is where this multiplication is coming in. And so then we would add the probability B3 times the probability of D given B3, bag 3. And you'll notice, so this is this other yellow line. And this is exactly what we have up here and how this probability is being determined. Now what you'll notice here is, as a little aside, is I took the intersection. So here, remember how these ands are just little intersections? I basically looked at a probability of D, dark chocolate, assuming all the different options from the first option. So bag 1, bag 2, bag 3. So in other words, you can kind of think of this as a partition, right? So I looked at a partition of my very first option choice. So the very similar thing happened when we were talking about passing exams. So here we kind of started talking about this, how we talked about like given things. And we could have done the same format, by the way, this tree diagram for this previous one, but I wanted to split it up. So you could have very easily combined all of these into like a, like I can do something a little small here. So one, I'll do this in black. You could always do 1, 2, 3 for the different bags, and then white, milk, dark, and you can have 3 lines for each one. but you'll notice how it gets a little difficult to read. So as long as you're able to see what each line is and the probabilities on each one, then you can do this smaller option here. But I figured this would be an easier way to kind of see things the first round. Cool. Okay, so back to exam. Sorry. So we have this example, and basically we kind of saw exactly how this is coming from. And so we started looking at what are the chances of passing at least one exam or passing exactly one exam. And it turns out, well, if we had set these, so let's look at this from a more mathematical perspective of events. So if I set the event A, so if I look at my event A, and I make it be pass exactly one exam. So in other words, I'm looking at the second set, right? It's pass exactly one exam, so I end up with this kind of formula here. And we can condition that on an event, right? So I can condition that to be event B, which is pass the first exam. So I can actually break this down into other things. So I can actually break this down to B. So what's the probability that we pass exactly one exam? Well, this is going to be the probability that we pass one exam and we pass the first exam, right? And so this one in particular is giving us this first one, right? So this is pass one exam, pass exactly one exam, condition, and pass the first exam, plus the probability that we pass exactly one exam and we fail the first exam. So the complement. And this is giving us the second component here. And so this is kind of the idea of partitioning that I was talking about. Notice how we have a nice partition of B and BC. And so in other words, we can actually always kind of do this thing. So here, if I multiply these out to the given conditions, I can kind of always do this no matter how many partitions that I have, how many elements in my partition, just like we saw for the chocolate example. And so this actually gives us what's called the law of total probability. And so the law of total probability is basically stating that if I have some partition A1 through AN, and I have some event A, then the probability of A is going to be given by A given A1 times the probability of A1 plus the probability of A given A2 times the probability of A2 all the way up to the probability of A given AN times the probability of AN. So again, a nice easy way to kind of see this and to verify this is true is remember that each one of these is equal to this intersection. Right? AN. And so for me personally, I think the second way of looking at it makes more sense on why this is true, right? Like I'm looking at A and I'm looking at what part is in A1, what part is in A2, what part is in AN. And since A1 through AN give me the entire thing, A must also be split into these different little components. And therefore we get kind of everything all at once. So that's kind of it for this video. Note that in the book, if you're following along the book, they call this the rule of average conditional probabilities. That's again old terminology, so no one really uses that. We just call it the law of total probability because we're adding the total, right, of everything in the sample. So next video we'll talk about independence and independent events and kind of how they work. So yeah, thank you.